Right, so we are on to the last section of 1.6, which is identifying and preventing any kind of vulnerabilities. Now, we've talked a lot about different types of attacks and different malicious activity. Now, this session is going to talk about how, as a company or as an individual, you can protect your network from those attacks. So most importantly is your network policy. And this is a document that will outline the rules and procedures that your company follow to minimise the chance of attacks or unauthorised access. So this will cover things like a test schedule to test the network and find any gaps and fix them. I know we've talked about the idea of an ethical hacker in big companies, but in a smaller firm that's likely to be one of your IT support team. The network policy will also outline any rules regarding passwords. They may need to be changed every 3 months, or they may need to include a symbol, that kind of thing. At a very basic level, the network policy will say we need usernames and passwords to prevent unauthorized people from accessing the network. It will also discuss user access levels. So which members of staff are able to access which documents? Can they edit those documents or can they just read them? Again, limiting access for entry to areas of the network where sensitive information is held. It will also outline the anti-malware and firewall software, the brand, the level of care, that kind of thing. And lastly, it will outline the encryption of any sensitive data. So let's have a look at some of these features of a network policy in more detail. So, a penetration tester is an individual who will attack, in speech marks, the network, but with the intention of bridging those gaps and making sure there are no weaknesses on the network before a less ethical hacker was able to exploit them. So essentially you're hacking, but then reporting your findings back to the company. Moving on to network forensics, this is where you are investigating the causes of attack on a network, so trying to find out what's happened so you can prevent it happening again. Now, in order to enable network forensics to take place, a company needs to have a way of capturing data packets, because those packets will need analysing. They will give information as to how the network attack took place. That information can then be used to prevent it happening again. Moving on to passwords. I feel like I'm a broken record here. We've talked about this enough. Yeah, they only let authorized users access the account now. They should be strong. And again, like we've talked about before, yeah, when you say they're strong, give examples. So they should be at least 8 characters long. They should use a combination of uppercase and lowercase numbers and symbols. And they must be changed regularly. The risk with changing regularly is people can't remember them and then write them down, or use a common word, in which case social engineering is potentially an issue. User access levels, again, we've talked about these a lot already, where you are determining which users can access which parts of the network. So if you take the school example, user access levels, staff can access the staff shared area and student shared, whereas students can only access the student shared area. What you're trying to do there is limit the potential for any damage. You can take that one step further by only giving read access to a file, only giving them write access if it's necessary. Moving on to anti-malware software, again, something we've already talked about quite a lot. The purpose of anti-malware software is it is going to identify that malware before it's done any damage to your network. Antivirus, as it says on the tin, identifies and destroys computer viruses. And firewalls, they examine all data entering and leaving the network, and then block any potential threats. And then to finish, encryption. If you're sending data across a network, like we've discussed a lot in this topic, when data's traveling or being transferred, that's when it's most vulnerable. So to try and give some level of protection to that, you can encrypt it. And encrypted data is essentially translated into a code that makes no sense until it gets to the destination where it's decrypted. So there's two key terms that we need to know about here. Ciphertext is your encrypted text when it's been scrambled and it makes no sense. The plain text is your normal file. So it can either be before you send it, and then it's encrypted into ciphertext to be sent across the network. It arrives at its destination and it's decrypted back into its usual state. Okay, so essentially, if we're sending our email here, it's encrypted, it makes no sense to anyone that intercepts it. When it gets to the destination, it will be decrypted using a key back into its usual format. I've chucked quite a lot of key terms at you there and also quite a lot of revision from previous lessons. So make sure you review, make sure you're happy.